All right. Um, for our energy project, we're presenting on nuclear energy. I'm Matthew.
I'm Emma. So uranium is the most commonly used to create nuclear energy, and it can be found in the Earth's crust in different types of rocks. The mining of uranium ore is usually by open pit or underground mining. The extraction of the uranium is by a chemical process, and later, when the uranium has been extracted, they distribute the energy using high voltage lines, and as the energy is transferred to consumer homes, the energy levels are lower. So the science behind nuclear energy, nothing is actually burned because the uranium atom nucleus absorbs a neutron and it is split. Uh, this fission creates huge amounts of energy in forms of heat, and it is a type of controlled radioactive decay. And uranium is used because it has 3 million times the energy of fossil fuels. And when changing the heat energy to electricity, engineering is used because the plant's conventional steam and gas turbines change it to electricity.
All right. So usage in the United States is pretty spread out because of the risks of meltdowns, which we'll get into later. Usage of the United States is limited to areas that are not prone to natural disasters like earthquakes or tornadoes or hurricanes or something that could possibly knock the reactor offline. Right now, there are 99 operating reactors in the United States, which ranks 15th in the world. And right now, the United States gets 19.5% of its electricity from nuclear. They get 797.2 billion kilowatt hours generated. And in California, we only get 9.3% of electricity from nuclear power. And you'll see the first map is of where all the nuclear reactors are in the United States. And then the second map on the bottom, all those black dots are where earthquakes happen. And you see that in the United States, we try not to put nuclear reactors in places that are prone to earthquakes because we do not want to have incidents like Fukushima happen. So that would explain why California only gets 9.3% of its electricity from nuclear power. Aside from meltdown, there also is a pretty significant negative environmental impact of nuclear energy, and that is that the waste that is produced from creating nuclear energy. The usage of uranium creates high-level radioactive waste that has to be stored somewhere, and the problem is where to store the waste, because not a lot of people want waste to be stored anywhere near them. And as you'll see on the bottom, the map, most storage facilities are in places that are not heavily populated. Uh, at these storage facilities, you'll see the top image. They're called spent fuel pools, and they are 40 feet deep and are filled with water. The uranium is placed in there, and then it is reinforced with concrete. And all of the storage is licensed and inspected by the Department of Energy to make sure that there's not a risk of the radioactive material leaking out into the groundwater or affecting the habitat in the natural way. A couple other also negative impacts. Setting up a nuclear plant, it takes a lot of land to create a nuclear plant, which has a negative impact on the local habitat. And it normally is near a natural body of water because it needs water to cool it down, which also can affect those areas. And then nuclear power plants also usually use diesel generators in case of an emergency, and the burning of diesel fuel to power those generators has negative environmental impacts, which you're all aware of. To counteract those negative environmental impacts, there are some pretty significant economic incentives. There is a pretty high initial investment cost for nuclear energy, but you'll see that nuclear energy, once you get it started, is pretty cheap. The initial investment cost is composed of four things: the bare cost, which is how much it costs to build the plant itself; the owner cost, which is finding the land, paying for the labor; and then cost escalation, which is the problems that come with upkeep and maintaining the plant; and then inflation, because people have to take out loans to get the capital to start these, and then paying the interest back on that can be hard. And you'll see in the top graph to the right, the first bar of each of those is the initial cost, and the initial cost is always incredibly high for all of those nuclear energy plants. But you'll see the second graph towards the bottom, you'll see that compared to other renewable energy sources, nuclear energy has the lowest cost per kilowatt hour of most of them. It averages about 11 cents per kilowatt hour, while other sources of nuclear energy like offshore wind or solar energy costs around 15 to 20 cents per kilowatt hour, which is why you'll see over time as other sources of energy like oil and coal have become more scarce and it has cost more to produce them, the cost for nuclear has stayed relatively the same, around 11 cents per kilowatt hour. So as those resources become more and more expensive, as they become more scarce, nuclear energy will become an increasingly more attractive economic incentive, as outlined in the image to the bottom left.
So one of the most well-known nuclear energy accidents was at Fukushima nuclear power plant on March 11, 2011. It was caused by the Tohoku earthquake, and it caused the active reactors to shut down the sustained fission reactions, and the tsunami further destroyed the energy systems for cooling the reactors. This led to nuclear meltdown, chemical explosions, and exposure to radioactive materials. The citizens in the area had to be evacuated, and there were no immediate related deaths to the radioactivity, but the risks of radiation-induced cancers increased. And later in 2012, many of the children living in the Fukushima prefecture area were found with abnormal growths in the thyroid glands.
And there's our bibliography.